Usual reminder that I'm only recording my own voice audio. So if you have questions, you can use the voice chat and it won't be part of the recording if that's a concern. Um, and I'm only recording the screen that I'm streaming, that you guys see the screen that's below my main one. So the Discord stuff is not in the recording either. Um, Okay, so what I'm doing now, I'm gonna just set this up. So I have my meme from last time, and I'm gonna duplicate this project to create a new project to work on as I add conditional logic into the meme project. So I'm gonna go to File and go to Duplicate. Um, I always want to do this when I'm starting a new project, even if it's just like a new version of a project, because that way I'm not going to lose the old version. So I noticed a lot of you guys are adding code onto your old projects, which is fine. I can still read all of the code. But in case you delete some of the stuff that is meant for another assignment, um, it's always a good idea to duplicate your work and then make your changes in the new copy. So I'm going to call this interactive meme 1. And I'm not going to edit this quite yet. I'm going to open up another window with just a blank project because I'll probably want to demonstrate some basics before I go into adding it into the meme project. Um, and so that'll bring us up to our main topic for today, which is conditional logic. I did the weird, uh-oh. I need to fix this issue with my notes app. Let's see, logic. Okay, there we go. Okay, so we're talking about conditional logic, and this is a really important topic for programmers because I mean, it's very foundational to how computers work in general, the idea of logic, but it's also just how we make decisions in a program. And basically, every program has tons and tons of decisions that we need the computer to make, and so conditional logic is kind of how we guide the computer's decision. So anytime you use, if you want to use video games as an example, the computer is making all these choices all the time. Like if I do something, what is the result going to be? If I find this key, then I can open this door. There's a lot of like things that rely on us knowing information about the environment and then applying rules based on that information to decisions that we make or things that we can access or things that we can do. So we use logic a lot. Conditional logic, so conditional refers to the conditions that we use to make decisions, and then logic is just the process that we use to make decisions. Um, and so, as I mentioned, when we're designing a program, there's lots and lots of points where the program has to make choices. And so we basically use logic to guide the program to make the choices that we want it to make. And we tend to reduce these choices into binary decisions. A binary decision means there's two outcomes. So something is either true or false. So even with a question that's more complex, that might have a lot of different answers, we start by reducing it down into binary options. So for example, when you're making choices about your, basic decisions in your day-to-day life, a lot of the times a way to simplify those decisions is to break them down into different categories and create binaries. So for example, when you're deciding what to wear for the day, there's lots of different components to an outfit, but there's individual choices that go into making decisions between multiple objects or multiple pieces of clothing that you might choose to wear. We use binary options to kind of reduce those down to make a yes or no decision. So, for example, if we are going outside and we want to decide if we're going to wear a jacket or what type of jacket we might wear, we might say, is it cold outside? And so by deciding, is it cold outside, or by learning whether or not it's cold outside, that gives us a binary choice. Well, if it's cold outside, then I need to do something to prepare for that. So I'm going to wear a jacket. And then we can say, well, is it like really cold, or is it only sort of cold? And we can start to make more and more decisions. We can break down a complex decision into these binary options. So that's what we're going to look at how to do in programming. These are the way we refer to this as conditional statements, where we make a choice based on whether something is true or false. So a binary option means there's only two options, and in programming, there's different ways of referring to it, but one of the main ways is something is either true or false. So we create a condition that can be either true or false, and then we have our program make a decision based on that condition. In JavaScript and a lot of other programming languages, we use a data type called a boolean that whoops, is either going to be true or false. Um, so actually, I'm going to open up the console for a second and just kind of demonstrate this. So if I type in true, that's just a regular piece of data like a 1 or a 0. And so is false. JavaScript understands that those terms exist, and we can use those to evaluate certain things. There's a lot of other types of data in JavaScript that have what's called truthy or falsy values. And we won't go into that a lot because it's not going to be super relevant for us. But you can evaluate other pieces of data besides a Boolean value as being true or false. Um, so there's a Boolean type, and we can say Boolean, and then it's going to be true. Uh, there's some falsy values like 0, if we evaluate it as a Boolean, is false, whereas 1 and 2 and other numbers are going to be true. Um, but again, we don't really have to go into all of that stuff because we're not going to use it a whole lot. But if I ask something like the type of true, that gives me the value Boolean. So a Boolean, it's just a term for something that's either true or false. It's just it's a value like a number, but it only has two options versus a number has, lots and lots of options, infinite options. A number could be 0 or 1 or 2 or so on. And a string has lots and lots of options as well. But a Boolean can only ever be true or false. Okay, so how do we actually use a Boolean and then use that to shape our code? One way to do it, the main way we're going to do it, is using an if statement. So an if just really stands for the word if, like if something, then we do something else. And so in JavaScript, we use the keyword if to evaluate a condition. And so just like when we're framing a question, if it's cold outside, then I'm going to wear a jacket. And let's see. Yeah, so okay, so here's an example of a Boolean value. So in a lot of the examples we've seen, we've used mouse X and mouse Y, which is constantly changing. It's a number that represents the position of the mouse on the canvas. But there's another system variable that we haven't looked at yet called mouse is pressed. And this is just going to be true or false. So it just tells us whether or not the mouse is pressed. So let's do a quick example. I'm just going to draw some text of the mouse's pressed value. And I'll put this in the middle of my canvas, and I'll make it big enough for us all to see. And so you can see right now it says false. That's because obviously I'm not pressing my mouse. And if I click on one of my mouse buttons, oops, I guess if I hit the right button, it gives me that context menu. But you can see it doesn't actually matter which button is pressed. If I hit my scroll wheel, it still shows true. But as long as my mouse button is down on the mouse, that value turns into true. And so you can see how that's really, really useful because anytime somebody's clicking on something, we can make something happen in our program. We can make our character jump, or we can turn the page of a book, or we can, see where their mouse is and then do something based on that. But it's really useful to be able to know if our user is clicking on the canvas or not. So how do we use that value? When we create a Boolean, and let's actually save this as my logic, oops, logic example. So when we use a Boolean, here is some pseudocode, which means I'm just typing out what the code should do, not what the code actually looks like. So if, let's say, if the mouse is clicked, I misspelled mouse, make the background pink. Okay, so very simple. Our background is get gray, but if we click the mouse, we want to make the background pink. So this is very similar to our, our if it's cold outside, I want to wear a jacket. So with our if statement, there's three components. There's the if keyword, there's the condition, which goes inside of parentheses. So it looks a little bit like our function, but it's, obviously a different structure. And then there is a code block, which is separated by curly brackets. And that is very similar to our function as well. Each one of our functions has a open and close curly bracket, and the code that fits in there is the only code that's part of that function. So it's the very same thing with our if statement. We're sort of like building a little smaller block of code within our larger function. So the condition goes in here. Um, And that condition can be anything that will either be true or false. So we already see with mouse pressed that it's either true or false. And so I can just put it directly in there in the condition box here. And then I can change the code based on whether or not it's true. And so essentially what this does is it looks at if the mouse is pressed, and if it's not, then it just ignores the rest of the code. And if it is, then it does whatever our new code is going to do. Excuse me. So what I want to do is draw the background pink. So I'm going to say background and then say pink. Sorry about that. My cough just keeps reappearing at inconvenient times. So anyway, I'm going to run this code now. So of course the background is not pink when I first run the code because the mouse is not pressed. And when I click on the background on the canvas, now we see the pink background. So you can see we can very easily change components of our sketch just by using if mouse is pressed. So that's a simple example. Let's look at a few other things that we can do with our conditional statements. So knowing whether or not the mouse is pressed is easy because it's going to be either true or false just based on whether or not we're pressing. So we don't really have to look at anything else related to what's happening with the mouse. But we may want to know other types of information about our sketch that are harder to parse out, that we need to use conditions for. And so this is a table of all the various conditional operators that we can use. And so this one is a little bit tricky because so far we've been using the equals sign to assign variables. So I can say something like variable x equals 1. And with this type of statement, I'm not actually saying that x and 1 are the same value. What I'm saying is that 1 goes into the variable x. And so that's why when I use the single equal sign, sometimes I say gets x gets 1 because I'm really assigning 1 into that variable. I'm not really saying that x and 1 are the same thing. The doubles equals sign, on the other hand, is saying that these two values are exactly the same thing. So if I say 1 equals 1, what I get in response from my program is whether or not that's true. So 1 double equals 1 gives me true. 1 double equals 2 obviously gives me false. And so I can use the double equals sign to find out if a condition is true or not. If I'm counting, for example, if I want to, count up to a certain number, I can say keep counting until this number equals 100, and my program will do that for me. So the double equal sign is when two values are the same. And I don't just have to compare numbers, I can also compare variables. I could say, I know that x is 1. And if I say x double equals 1, that gives me true. The value that is stored in x is equivalent to the value of 1. If I say x double equals 2, that's going to be false because they're not the same value. I can also compare other types of data like strings. I can say hello double equals hello, and that's going to tell me it's true. And if I change one of the characters in my string, like add a capital letter, then it's going to say no, that's false. So it's looking at all of the characters in the string, and if they're all the same, then they are equivalent values. And if they're different, then of course they're not. So another kind of tricky thing that we can do is we can actually ask the opposite of that. We can say, is something not equivalent to something else? So I can say, is 1 not equal to 1? And of course, that's going to be false. So that's where it gets a little tricky. We probably won't use this too much, but just so you know, if you see that in some code somewhere, that exclamation point means the opposite. So it means that this is not the case. So if I say 1 does not equal 2, now it's flipped around. That actually is true. 1 and 2 are not the same value. We can also compare numbers much the way that you would in algebra. We can say, is 1 greater than 2? And I'm just using the angle bracket, which are located on the comma and the period keys, kind of at the bottom of your keyboard. And you can type them uh, just using the shift key. And so is 1 greater than 2? Of course, that's not the case. Is 1 less than 2? Yes, obviously that's true. Is 1 greater than or equal to 1? Yes. Is 2 greater than or equal to 1? That's also true. And then we also have less than or equal to, so I can say is 1 less than or equal to 2? That's going to be true because 1 is less than 2. So we have all those types of operators that you would normally see in math. We also have a special one in JavaScript which compares types. This is another one that we're not going to have to use a whole lot, but you will see this in a lot of code, and most people say that you should always use this. And this is the triple equal sign. So we have the double equal sign, now we have the triple equal sign. And I'll show you where this is useful. If I say 1 double equals 1, that's going to be true. But if I say 1 double equals the string 1, that's also going to be true. And so we can see by looking at this that that kind of makes sense. 1, the number, and the 1, the string, both have the value 1, but they're different types. So if I say 1 triple equals 1, that's when I get false. And this is a sort of like quirk of JavaScript. Most languages would not behave this way, but it gives us that triple equal sign so we can be sure that we're actually comparing values of the same type. And you might think that this is something that would never come up, but it is actually an important thing to know about, probably not for this semester, but eventually as you learn more coding structures, this is something that you'll want to be aware of. So we won't go into too much detail there because I don't think we'll see it too much this semester, but that is uh, another way that we can compare values. All right, so let's use this to make some more decisions about our program. So we can test to see things about the program, like where the mouse is, where different parts are. And so what we want to do is test to see where is the mouse, not just if we're clicking. So I'm going to add another condition down here. And I'm going to write some pseudocode first. So I want to say if the mouse is on the right side of the canvas, let's draw a circle. Okay, so how do we know where the mouse is? Well, we can use mouse X. So let's draw mouse X down here as well. Let's say text mouse X, and we'll put it at 200 and 250. Okay, so we can see that the number representation of mouse X gets higher as I move across the screen. So 0 on the left and 400 on the right. And so the way that I can know which side of the screen the mouse is on is just compare it to another number. I can say if the mouse X value is greater than 200. So I'm just going to use half the width here. So if that's the case, let's draw an ellipse and we'll just draw it in the middle of the screen. So we'll put it at 200, 200, 200. Just very simple. So now we see when the mouse is on the left side of the screen, there's no circle. And when I get to the right side of the screen, now we have a circle. And so this is very useful for determining where your user is clicking. This is kind of the basis for how all user interfaces work. We need to know where the mouse is and then draw stuff based on where the mouse is. And we'll look at more sophisticated ways of doing this. This isn't really that exciting because there aren't that many use cases for just like if your mouse happens to be somewhere on the screen, draw something or not. But we'll see more complex versions of this later in the semester that have more obvious use cases. Okay, so we can compare values to determine things about the environment. Okay, so we've learned what we can do with an if statement, but there's another thing that we can do, which is if something is true, we want to make one choice, but then we have else, what to do if the thing is not true. So far, we haven't handled that. And so you can imagine that's kind of the follow-up question. So if it's cold outside, I'm going to wear a jacket. But if it's not cold outside, then I have some more choices to make. So that's how else works. If the first condition isn't true, what are we going to do instead? And so it's very simple to write. I'm going to put it back over here. So if the mouse is on the right side of the canvas, draw a circle. Else, meaning whatever the opposite of the original condition is, let's draw a square. And so all I need to do here is after my if statement, I can write else. And else can only follow an if statement. So I have an if statement. I can obviously just write more if statements. This if statement is directly followed by another if statement, but an else has to come after an if statement. If I try to start my logic with something like this, else, background blue, something like that, this is going to give me an error. So else, let's see what the error says actually. Unexpected token else. So yeah, else only can follow an if statement, but it really just goes right after it. It just goes right after the last bracket, and then it has its own brackets. It doesn't have a condition because else is just whatever the opposite of if is. So if this is true, we do one thing, and if it's not, then we can have this fallback option. We can have this else. And so else, let's draw a square in the same position. Okay, so we have if and else. So if we're on the right side of the canvas, we get a circle, else we get a square. And let's put the rect mode center. Not that it really matters, but this way they'll line up. So you can see as long as my mouse is over here, we get the square. And if it goes to the right, then we get the circle. So that's our else statement. And again, it's just how we deal with the leftover condition. So if something isn't true, then we may want to have another thing that we do. Okay, to complicate things just a little bit more, if we have more than those two possibilities, we can add in an else if. And this is where things get a little bit complicated because we're still making binary choices. We're still breaking down a complex decision into true or false statements, but we can make a series of them. And they also kind of rely on each other. So we can say, in this example, we have a few separate conditions that we branch out. So we have, if it's snowing, I'll wear a heavy coat. If it's raining, I'll wear a raincoat. If it's cold, I'll wear a jacket, or otherwise I'll wear a jacket. And so this is when we're starting to make more complex decisions like this, we have to make sure that we do things in the right order. So, if we ask if it's snowing first, then we're going to wear a coat. But if we asked, is it cold out first, and decided to wear a jacket, then we might not get to the choice where we where we wear a coat, which might be the appropriate choice. So we have to kind of order our conditions in the order that they're most important. And so I'll show you an example of this. We're going to make a little stoplight, and we're going to see how we might kind of mess this up. So I'm going to expand the size of this a little bit. I'll just put a little stoplight over on the right. So right now I have some conditions related to the mouse being over here, but let's make a little stoplight on the right side of our canvas. So I'm going to make another comment here. And I'm going to say making a stoplight. So if the mouse is at the top third of our canvas, we're going to have the red light. So if mouse is at the top third, oops, draw a red light. If mouse is in middle third, and I'm just dividing the canvas into thirds just visually, so you know, uh, whoops. Basically, whatever this number is, we're going to have red up here, yellow here, and green down here. Just our typical stoplight. And I actually don't remember how, maybe I'll change the canvas size to make the math a little bit easier. We'll just do 300. Okay, and we can always fix that later. So 300 will be good. That'll just make the math nice and simple for this. Okay, so if the mouse is in the middle third, draw a yellow light. And if mouse is in the bottom third, draw a red light. So there's three possibilities here, but there's actually a few different conditions that we have to check for. And the order that we do them in is important. So I'll show a few different examples of how to, well, we can code it up and then we can show how we might screw this up. So the first question I'm asking is the mouse in the top third? So if I have my condition, mouse Y, and so the way that we want to ask this is basically if our canvas is 300 pixels tall, we know that the top third is between 0 and 100. We know that the middle third is between 100 and 200, and then the bottom third is between 200 and 300. So if we're in the top third, the mouse value, where this mouse is, we know that has to be less than this first 100. And then we can keep going from there. So let's check this first. So we'll say, so if mouse Y is less than 100, then let's do a fill of red, and let's draw a circle, and we'll put it at, for the X, I want to put it over to the right, so I'll try 500, and I want to put it at the top of my canvas, so I'll try 50, and I'll make it 100 pixels tall. Okay, so there we go. That kind of screws up my previous program, so let's put some defaults up here. So we'll just say fill 0 stroke 255. Oh, my text is all the way at the bottom. Okay, let's move this text up to here. And we can say fill, oh no, it's the other way around. Fill 255 stroke 0. I guess our text, okay, let's change our text. Fill 0. Okay, there we go. Anyway, so we have our red stoplight over here. We can say no stroke for this section. We don't need a stroke. Okay, so we have our first part of our stoplight, and you can see it only appears when my mouse is in the top third of the canvas. As soon as my mouse goes below, that stoplight disappears. Okay, so now if we just add another statement, so our second part is 200. So if our mouse is less than 200, then we want to draw our yellow. So if I say if mouse Y is less than 200, fill, whoops, yellow, circle, same X, we're going to move it down on Y, so I'm going to do 150 on Y, and then 100 for the size. Okay, so now notice what happens. I get my red light when my mouse is up here, which is correct. I get my yellow light when my mouse is down here, which is also correct. But if I'm up here, I get both of them. And so let's look at why that happens. So with the code that I've written so far, I'm saying if mouse Y is less than 100, so if my mouse is up here, then here's 100, and here's 200. So it is less than 100. This, whatever this pretend value is right here, is definitely less than 100, so that's true. But it's also less than 200, so that's also true. So that's why we see the red and the yellow light at the same time. So there's multiple ways I can deal with that, but the simplest one is I just put an else before this if statement. And so what that does is it ties my second condition to the first. If the first is true, then we never go to the second. But if the first is false, then we say, well, what about this condition? Else if this condition. And so now when I run it again, we get red and yellow on their own. Okay, so we have our last one at the bottom. And so there's a couple different ways we can do this. We can say if mouse y is less than 300, okay, so that would give us our last condition, fill green, and we get our circle 500, 250, 100. Okay, so we have the same issue here, right? Because our green, since our mouse is always less than 300, it's always basically going to be less than 300 because our canvas is only 300 pixels tall. So that green is always going to be there. So I could add an else if here, but I don't actually need one, right? Because it's the mouse, if it's not one of those first two, then it's definitely the third. So usually, if I only have three conditions, the last condition is just going to be else. It's going to capture everything. So I can have, there we go, we have red, yellow, green. If you had like more, more lights, then I would need another condition. But as far as the context of this program, since I only have those three options, I only need to evaluate the first two conditions. If those are both false, then the final condition has to be true. And you can use as many else ifs as you want. You can have as many conditions in here as you want to. You can just like keep adding them up. And you also don't have to have an else. I can have an else if without an else, and my program will still run if I just have the two. So you can kind of use these in a lot of different ways, but that's just one example. Okay, I think I'm ready to move on to changing my uh, oh wow, I go into some more complicated stuff. Let's cover this stuff on Wednesday. Let's kind of break this up a little bit. So I'll cover this extra stuff on Wednesday when we cover our second example where we're going to use a counter. But right now I want to show you guys how to actually implement this um, in our uh, sketch. Oh, I guess right here it says, can we rewrite the above using variables? Let's do that and then we'll move on. Okay, so one last little thing here. I can use variables here. So another way to write this, especially if the height of the canvas might get bigger or smaller, instead of saying 100, I know 100 is a third of the height. So I could say the same thing as height divided by 3. Okay, so that one's pretty easy, but the second one is a little trickier. This one is 200. So that's 2/3 of the height. So how would I get that? I could say height times 2 divided by 3. I could say, height over 3 times 2. Either one would actually work fine. Okay, so we can use our system variables at the same time as our conditional statements. This way, if I do decide to make my canvas bigger, you can see that, even though the circles are in the same position, you can see that the mouse is actually changing at different points. So we can use variables there if we want to. Okay, so we'll cover the more complex logic next week, but I want to go in and show how, or sorry, on Wednesday, but I want to go in and show how we're going to use this inside of our meme. So I'm going to go over to our meme, and you can see right now our meme has these two parts, and I'm going to do a really, really simple version of this. I'm just going to make it so that when you click, you basically just see the second part instead of seeing it at the same time. So it makes it interactive where I can click to reveal the second part of the meme. What we're going to do on Wednesday is a little bit more complicated, but you can do either one for your homework, just to kind of give you an option there. So I'm going to clean this up a little bit first, and then I'll add the new code. So let's see. I'm going to turn that off for now. So let's see. Why is the dog moving around? Oh, I have it up here. And I have this like tint. Okay. So let's put this down here. Oh, I guess I'm just drawing both my images here. Okay, so let's just change this to 0, 0. And for the text, I have these two different texts, but I'm going to put them in the same place. Okay, and let's make my canvas small again. Okay, it's even smaller. That's very small. Okay, so right now I have two images and I have two texts, and I just want to crop them. And I'm going to load my other dog image that doesn't have the cutout because that's going to look kind of weird. Oh, but I sized it down. Uh-oh. Okay, let's size down our dog image to width by height. Okay, there we go. Okay, so I have these two different memes. I have one with a cat and one with a dog, and instead of putting them on top of each other, I'm going to use the mouse to switch from one to the other. So I'm just going to use a really simple amount of interactivity. And so what I'm going to do is I'm going to come down here to the bottom of the program, and I'm just going to say if. So I'm, doing my conditional statement. So if mouse pressed. So if the mouse is pressed, mouse is pressed. And a lot of the Boolean variables use that syntax like mouse is pressed to sort of like state it as a true or false condition. Like mouse is pressed has to be either true or false. Okay, so if mouse is pressed, then we're going to draw the cat image. So I'm going to, or actually, I guess the default is that the mouse is not pressed. Okay, so let's draw the dog image if the mouse is pressed. So I'm just going to steal that code and throw it down here. And then I'll put the text on top, like so. And so for this one, I don't even need an else statement because there's only two conditions. So if the mouse is pressed, we're going to draw the dog, and by default, we draw the cat. So there we go. We have I'm a cat, and then if I click the mouse, it changes over to a dog. So it's really that simple. I just moves a little bit of my code into the inside of this if statement and create that condition if the mouse is pressed. And it's really pretty simple. It just makes it so that when I click the mouse, the program sees the mouse is pressed, and so I can add in the new content. And then I can put whatever code I want to it. So I can draw the dog, I can draw the new text, but I can also, add all sorts of different stuff if I want to. So that's the really simple setup for this assignment. And we'll go over a slightly less simple setup on Wednesday where you can cycle through different texts or different images or whatever you want. We'll have like that. That one's a little bit more complicated, but it still uses Boolean logic. Another thing to mention is you don't actually have to change the image here. Like if you just wanted to change the text, you could get new text, but then you'd have this problem of, oh, I see both texts at the same time. So that's when you would want to use the else statement. I could go in here and I could say else, and I can move my cat text down here. And so now we don't draw the cat text at all unless we're not pressing the mouse. So we can just switch between those two pieces of text. But if I bring the dog image back in, this will work the same way. You could also just change the image in the background and leave the text the same. You can really do whatever you want. It's just using that condition, whether or not the mouse is pressed, to make some change to the code. So it doesn't have to be exactly the way that I've set it up. Like whatever you could imagine adding or subtracting from your project, you can put into that conditional statement. I'm going to stretch out the cat a little bit just to fit in. So I'm going to use width and height for the cat. And let's actually just even this up. I don't care if they're kind of stretched out looking. Or maybe we can just make the canvas bigger. It's a little too small. Okay, that looks good. We probably want to move the text down a little bit, maybe to 300. Okay, so I think that's it for tonight. I will put this example in the chat for you guys to take a look at, along with the other Boolean example I did before. And let's see. Let's take a look at the assignment real quick before we wrap up. So for the interactive meme slash logo, this is assignment 6. This is due next week, so the next weekly assignment. All we have to do is add a conditional statement that changes something about the image. So it can be as simple as what I just showed. You just click and something about the image changes. But we'll do a slightly more complex version on Wednesday, and we'll go over how that works. But as long as there's some interactivity, that something happens when I move the mouse or click the mouse or the keyboard or whatever it is, that's all we're really looking for, as long as it uses an if statement. You could do stuff like this probably without if statements, but we want to use if statements to practice our conditional logic. All right, so I'm going to stop here.